Alright, so today I'm going to be showing you how to solve a rational function with the application. Yeah. Alright, so if Joe rows his boat 10 miles upstream in the same amount of time it takes him to row 20 miles downstream, if the current is 5 miles per hour, how fast can he row in still water? Alright, so basically what's asking, he rows 10 miles upstream, which is against the current. So if the current's 5 miles per hour, we start off by putting 10 over x, which would be how fast he's going in still water. And then since he's going against the current, we put minus 5 because that's the current, and that's slowing down 5 miles per hour. And then if in the same amount of time you can go 20 miles, you'd set it equal to 20 over x plus 5, because he's going with the current, so that's making him go 5 miles per hour faster than if he was in still water. Alright, now the least common denominator, or the LCD, would be basically just this and this, because those are the two least common denominators. And so for the least common denominator, you'd get x minus 5 and x plus 5. Alright, and so now you take that least common denominator and you're going to want to put it above the 10 like this, and then do the same over the 20. Alright, and now here you're going to look at these two things, and then if x minus 5 is anywhere up here, you'd cancel one of them out at least. So x minus 5 is right there, so we cross that out and then cross that out. And now you go over to this side and do the same thing. X plus 5 is right there, so we do x plus 5, cross that out, and then cross this out too. And now here you're going to want to basically distribute the 10 and the 20 to whatever's left above it. So you distribute the 10 to the x and then the 10 to the 5, which would get you 10x plus 50. And then you do that same over here, and they're equal to each other, so you'd set it equal. Be 20x minus 100. And now here, you can basically do whatever you want. You can start on whatever side you want with minusing the constant numbers, but I think it's easier to do positive, so I'm gonna plus 100 because you're canceling it out, and you have to do it on the other side too, so plus 100 on both sides like that, and then you get 10x plus 150 equal to 20x, and then since 100x cancels out, it's not there anymore. Alright, and now you can't have two variables on each side, so you have to get rid of one of them, and you can't take everything off this side, so you'd have to go to this side and take away the 10x, which would be minus 10x on that side, and then minus 10x on this side, which would get you 150 equal to 10x. And then now you would divide them both by 10, because that's the x, and then you get 15 is equal to 10. No, x, sorry. Alright, and yeah, that's basically how you solve a rational function application. Okay, so here is the second part to solving rational function applications. Alright, so Tim and Jim are driving to the lake. Tim lives 50 miles away from the lake, and Jim lives 30 miles away. But they both leave and get there at the same time. If the speed limit is 40 miles per hour the whole way there, what was the difference in the two speeds? Alright, so since he was living 50 miles away, he would have driven faster, so you're going to add x to his speed. And he lives 30 miles away, so he was going slower, so you're going to subtract x from his speed. So you'd sub the equation like 50 over 40, because 40 is the miles per hour there, plus x because he was going somewhat faster than the speed limit, and since they both went at the same time, you'd equal it, and it would be 30 over 40 minus x because he was going slower than the speed limit. Alright, so now the least common denominator for this one would be 40 plus x and 40 minus x. Now you're going to put that above both of them. Alright, and now you do the same as you did the last one and cancel in. So 40 plus x right there, 40 plus x right there, 40 minus x right there, 40 minus x right there. And then just like in the last one again, you're going to distribute 50 to 40 and x. So you'd get 200 minus 50x equal to, do the same thing with that, 30 to 40 and 30 to plus x, be 120 plus 30x. Alright, and now you're going to either subtract 120 or add 200 to both sides, whichever you want to do, but I'm going to minus 120 from 200 because it's a smaller number, which would get you 80 minus 50x is equal to 30x. Okay, and now you're going to want to add 50x to 30x, and also so it cancels out on this side. Alright, and that would get you 80 is equal to 70x. Now you're going to divide them both by 70. Which would get you 1.14 is equal to x, which is also the difference in their speeds. So that's how you solve rational function applications.